this video. Just FYI. Okay, Krista, we're doing problems for homework.
Hey, girl.
Okay, so in this one, it's going to be oxidized to oil because it went from a 3 to a 4, so it lost 1 electron, yeah?
Yeah.
Okay. Now, notice, I just want to point this out right now, we have 2 carbons and 1 carbon. So if I know that we're going to have to change these coefficients, we're going to call temporary coefficients, because I can't balance those carbons if I can't change the vein coefficients. So that's why they're called temporary. So right now, your temporary coefficients are coming from your action of balancing electron transfer. We have 5 electrons transferred here, 1 electron transferred here, so what would be your multipliers? 5 and 1, right? So 5 here times 1 here, so the 5s get to go yay here, and then the 1s get to go here, not that one, and here. Okay, now that we've balanced the electrons, how many total electrons are transferred? How many?
6.
How many electrons are transferred on the rig one? 5. Well, where are they transferred to? I'm sorry, let's go back the other way. How many are transferred on the oil one? 5. Well, where are they transferred to? The rig one. There's a net total of only 5 electrons transferred. It looks like there's 10 because you're talking about 2 different things, but they work together. So you transfer it from A to B, so from oil to rig. Okay, so there's 5 electrons transferred. Let's start to balance here. So K's, I see the 2, I see the 1. I have to change this. Okay?
Wait, I didn't realize you could change it.
That's why I said those are temporary. If you have to change it, you got to change it, because if not, you can't balance the mass, and that's a big no-no, right? So I'm going to put a scratch with this on blue. Yeah.
So if you change it on the equation itself, do you change it on the rig and the oil also?
Yes, because I want to make sure my electrons transferred equal to electrons gained. So I'm going to show you how that works. It's just in the back of your mind. You're keeping an eye on that, okay? So this is going to be a 2 now, okay? Now, when I add a 2 there, I'm actually saying I have 2 manganeses that are transferring electrons. Well, each manganese transfers how many electrons?
7.
Each manganese transfers 5 electrons. Well, now I have 2 of them doing the same thing. So how many electrons total is this manganese going to be this thing transferring? So what I've essentially done is I multiply that by 2. So I balanced out my potassiums. So that means this right here, if I put a 2 here, I have to put a 2 here. All right, so right now I'm saying that I have gained a total of 10 electrons. That means I have to also show that down here with my oil. And that's actually going to help us work out our balancing. So I know if I have 10 electrons here, I have to have 10 electrons here. So to these, I need to look and see. I'm going to put 2 right there, but I'm going to see what I have to do with those 2 coefficients. Notice earlier how I said you have 2 carbons and 1 carbon? Which one of these do you want to change? This one, because I need to balance it out with that 2 carbon right there, right? So it's not always going to be the fact that you're changing both temporary coefficients, but it's a possibility. So I'm going to take away this 5 here and put a 10, because 1, you can see 5 and 2, I have 10 carbons, and then 10 carbons here, so check, that's the atomic balancing. And then now let's look at our electrons. Each of those carbons lost how many electrons? 1, because it went from a 3+ to a 4+. So if each carbon lost 1 electron, how many total carbons here? 10. How many here? So total electrons transferred? 10, and that's what we had up there. Okay, so this is like a lot of checking in your head. I'm really sorry. I do not like balancing this way. Only when you're in a real struggle do you have to balance this way. The other ones today we're going to do, I think, are easier. Okay, so finish balancing. We got, so far, manganeses check, oxygens here, what's that, 8, 28, 32, and over here we have, that's 32, or 32 O's, 24, 32, is that right? 20 plus 4, 24, plus 8, 32. Where does this lonely one go? Well, we don't have to balance. We'll see here. I could just actually look here and show you. Are sulfurs balanced?
No.
Oh, let's do sulfur first. If I have oxygens in like 15 places, I usually hold them for last. I was just going in order here. So sulfur here on this side, and the sulfur twice over here. So I have 1 sulfur and then 2 sulfurs. Oh, I'm sorry, 3 sulfurs. So what do I have to add here? a 3. So 3 times 1 is 3 sulfurs. And then 3 sulfurs over there, check. All right, let's do hydrogens, because that one might be a little bit easier here. How many total hydrogens on this side? 10 plus, okay, so that's 16 hydrogens, and then, no. Okay, so what are you going to add here? 8. Okay, now, I've changed up some stuff. How many oxygens are over here? 8, 28, plus 12, 40. Yeah, 40. And then 24 plus 8, 32 plus 8, score. Okay, that's a piece of work, piece of art, yeah. I didn't change that first 5 because the reason I changed this number is because I need to have a total transfer of 10 electrons and have a total of 10 carbons. If I change that number, it's going to make me have 20 carbons. So in the end, it works out because that 2 serves as like a second multiplier. So you put your temporaries there, and then you finagle it, and you can change what you need to change to balance it, atoms and electrons. So this one I had to change this one and this one because I had manganese. Why did I change that to begin with? Oh, because I saw the 2 here for the potassium, and I had to put 2 out here. So I put the 2 there, and so then I had 2 manganeses. Then I saw I had to put the 2 here to balance the manganeses. I'm going to play with it a little bit, okay? Hold that homework for right now. Does that make more sense?
Yes.
Okay. I'll do another one, but I'm going to wait and do another one. I'm going to do acid-base stuff, and I'll let you guys practice. I'll do acid practice and then base practice. And I still have barium sulfate needs to be taken out. Okay, so here's your next little bit of information. So I told you there's 3 ways to balance redox reactions. And this one, I have fun with. I like it. Okay, we're going to use this one a lot in the flint NIEs. And so the rest of the flint ones, oh, by the way, have all your stuff. Don't forget to pass it out to you. So you're writing, or make sure you're doing the one together. You'll use this one in a lab with redox titration. You'll use this when we get to electrochemistry with batteries and stuff later on in life, aka chemistry. So you're going to use this one a lot. So it's very, very, very important. They did not give me a little. Oh, because I'm not very good. Okay, I'll be videoing. Okay, so remember your half equations, half reactions look like? For example, we had one yesterday like this, copper 2 yields to copper plus, 2 electrons go on that side. So it's not the full thing, it's just half of the story. It's either the oxidation half reaction or the reduction half reaction. If I show you this one and I say, okay, electrons are on the right side, oil or rig? Rig, right? So reactants, the electrons are on the reactant side, it's rig. The reason that's a rig is because you can see these electrons are being gained right here. Okay, so right after half reactions, you have to balance everything other than H's and O's, because H's and O's are commonly used in all redox reactions, so we wait and balance this for the second part of this process. So that might be like a chromium or a copper or a potassium or something like that. Then you're going to balance your O's first. I always remember as O as in like OH, 3H, 3H. O comes first. When you're balancing, have to balance on first, and then you have to balance the H's second by adding these appropriately these 2 different substances. All this right here is just doing atomic balancing or balancing the atoms. Now you're finally going to start to look at charges and how to balance the electrons. That one's pretty easy though. I'll show you how to do that. The way you make electrons lost and gained is by using a multiplier. And then the way that you finalize this process is by taking both half reactions and putting them back together as a summation. So you're going to add the 2 half reactions back together, and if there's anything on either side that's the same, either side, reactants and product side, If they're the same, you want to simplify, so cancel things out left and right like we did in that alum lab on the left and right hand side of the yield arrow. Okay, cool. I have more stuff to pass back, don't worry. This is a shortened version of how you do this. This is the more extensive version. It's got a little bit more words. If you want to take a picture of that, do not write this down. But this is, just says exactly the same thing, but it's like what I said out loud is on here. So what I said out loud is on here. So you can stand up, you can come closer. This is online, whatever.
Okay?
But I do need, I'm moving in the next like second here because I gotta see if I can do one example before Allison goes. Same exact thing, but in more words. Alright, next thing we're doing is an example, so get ready for that example. This is just like a memorized process, and then you go with an example, okay? Alright, so I'm going to walk you through this one first. I did notice this typo earlier. There was no potassium on that product side. It had to be, because it's how reactions work. Okay, so let me show you this first, and I'm going to make it so you can't see everything right now. Right down the very beginning. Right there. You've got potassium dichromate plus iron 2 sulfate yields chromium 3 sulfate plus iron 3 sulfate plus potassium ion. Two potassium. Whenever you're doing any kind of reaction, it sometimes makes life simpler if you not like write the NA, but you eliminate any spectators that you know are always soluble or specifically soluble in this situation given. So potassium is always soluble, so it's going to be ignored, as seen here. In this case, I can look right now, and I can tell sulfate is not involved in the redox reaction, or sulfur or oxygen in this case actually. Because if sulfate is here, and sulfate is here, and sulfate is here, you know sulfate has that -2 charge, right? Yeah, sulfate is -2. And the oxygen is a -2. That sulfur, in this case, and this case is always going to be the same because it's not changing it, who it's associated with. So if it was sulfite, it would be a different story. If it was sulfide, it would be a different story. But if it's still sulfate, 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 and there's no S's anywhere else, I know that sulfate is not involved in redox because it never changes. It never changes the electrons, period. So technically, it's a spectator here, and so we're going to take it out of the situation. So we're left with dichromate plus iron 2 yields chromium 3. Now, how did I get this chromium 3? What was my process up here? Okay, so I uncrossed. This 3 went back up here, this 2 went over here, and I can tell you that chromium itself is a +3. And so the way that works out is because when I had 3 of sulfates, totally on the right-hand side, sulfate made a -6. And then on this side, I had 2 chromiums with a 3+, so I made a +6, so they neutralize each other. All right, so that's how I got the chromium 3, and the iron 3 came from the same thing. Good here? Just broken it down in simpler terms. Sorry, there were fruit flies in my room. People bring projects in with food and then they don't throw them away. Okay, I'll start here. The first reaction is going to be you pulling out the 2 reactants and products that relate to one another. I pulled out the dichromate first and the chromium. What was the first step after you wrote your half reactions on your little cheat sheet there? Not O's yet, so it says it's right, balancing other than H's and O's, right? All right, so that's what I've done here. So I've pulled out the half reaction, check. All I did is just pull it out. I'm not doing anything to it. Now I've added a 2 here to signal that I'm balancing chromiums because I had 2 chromiums on the reactant side and I needed 2 chromiums on the product side. All right, next step. Okay, I'm going to quickly show you that I do have the other half reaction. It's right here. I'm just not using it just yet, okay? So the other half reaction was the iron and the iron. You just choose the things that are similar. Okay, so back up here. I have 7 O's on this side. I have 0 O's on this side. So how many waters do I need to add to the right side? 7. Okay, even though I'm adding 7 waters, I'm technically adding 7 oxygens because there's coefficient of 7 and a subscript of 1. Now I've got a lot of H's on the product side. I need to add them to the reactant side. How do I add H's? H+. With H pluses. How many H's on the right side? 14. So I'm going to add 14 H pluses over here. It's just back and forth, back and forth. Okay. Now technically I have my chromiums balanced, my oxygens balanced, and my hydrogens balanced. The next thing to do is to balance your electron charges. What is the total charge on the product side if you include everything here? There's 2 of them though. Plus 6 total, because the water is neutral and each of the chromiums carry a 3+ charge. What is the total charge over here? I have 14 H pluses and 1 chromium with them 2 minus. Plus 12, right. So I've got those 2 minus and the 14 plus come together to make a 12 plus. All right, my job is to add electrons. I can't add protons. Protons, that means you're destroying the nucleus of something. That's totally awful. Awful people, okay? We want to add electrons. Do I add electrons to the right, or to the left side or the right side to make them equal? Okay, so how many do I want to add over here? 6. I'm going to add 6 electrons here. And I have this better. I'm just showing you the process before I tell you everything. So I add 6 electrons over there to create charge balance. All right, so now I'm going to show you that here. I'm down on the bottom though. So here's where we are. We add 6 electrons to the reactant side to balance those charges out that we just determined. Now we're done with that half reaction. What's up?
She said, dumb question.
No.
Yeah, so you could lose electrons on the other side to make it fun.
Right, that's probably you. Okay, you write down the second half reaction there in green. Okay. Anyway, so right here we have the 2 and the 3. This one's really easy. The ions are balanced. There's no oxygens. There's no hydrogens. You just go straight to charge balance. In this case, we have an overall net charge of 2 on the reactant side, net charge of 3 on the product side. So to balance it out, you have to add 1 electron to the product side, because that's going to bring that 3 plus down to a 2 plus, which is what the balance should indicate. So now this one's done. All right, next step on your list of things to do is to balance the electrons, or make the electrons gained equal to the electrons lost, yeah? All right, now here's where you look at both of the half reactions. You decide what multiplier you want to use. We have 6 electrons here, and we have 1 electron here. So your multiplier here has to be a 6. So you multiply this entire half reaction by 6. Everything gets a new coefficient. So the iron becomes, it's down here. Sometimes I don't do it until the end, because I actually, looks like a lot of work, but most of my work is about this big, so I do it all together in one, like on these 2 lines right here. But down here you can see the 6 gets distributed here, 6 gets distributed here, and here. That top one just got multiplied by 1, so we don't change anything. So before I cancel anything or do anything, I'm going to pull all of this information down into one big humongous BCE. So I pulled down my 6 electrons, my 14 H pluses, my dichromate, my 6 irons, and then on this side of the arrow, the right side of the arrow, I have 2 chromiums, 7 waters, 6 iron 3s, and 6 electrons. Give me a thumbs up when you get your BCE down. It's long. I know. But it's nice that there's a step-by-step process for this. It's not like, let me guess and throw a number in there and see what works out. So that's why I like this better. Okay, I'm just going to use that. Okay, so the things that are the same on the reactant side and product side, right now you can see off the bat are what? 6 electrons, and that should always work. You should never, 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 ever have electrons left over in your final BCE if you balance your electrons correctly. And that's the goal. Redox, balance electrons, equal change. What else do you see as common? Nothing. Okay, so bring it all down. That's our final answer. Yay, 1 down. Yay. We're going to do some practice problems from your worksheet. So, if I had asked you to balance this before, and I said balance with acid or balance this redox reaction, it's hard to do because there's no method to this madness almost when you look at this reaction up here. Like, when you're looking up here, and you see all this mess, there were two over there. You might be able to balance the atoms, but you probably wouldn't be able to balance the electrons, and so something would come up amiss. Question, Terry? You good? Okay. So now if we have this reaction, I can have you do mole ratios, I can have you do stoichiometry. It's the same dang thing, it's just balancing takes a little bit more. So if I said, okay, I have 4 moles of the potassium dichromate. That's a limiting reagent. So if I told you you had 4 moles of this, how many moles of chromium would you make? What's the mole ratio? No, I said you have 4 moles of this. That is not the number. That is not that coefficient. Right, it's 1 to 2. So if you were given in the problem, you had 4 moles of the dichromate, and I said how many moles of this could you make? You would do 2 to 1. So then you could say 2 moles of chromium 3 plus are made for every 1 mole of the dichromate used. Therefore, I'm able to make 8 moles of the chromium 3. So this is just a new way to do stoichiometry. It just has a process before we get there. Okay? All right. Let's do like 2 or 3 of these. I guess we'll do the first one. These are half reactions already, though, so I just want you to be able to tell me how to balance this out in acidic solution. Okay? So BI, you might want to write this one out. This is really little. All right, there's our half reaction, pulled out from some general BC that was given at the very beginning. Not BR, BI. Are the non-redox things balanced? I'm sorry, the non-H's and O's balanced?
Yeah.
Yes. Okay, what's your next step? Add H2O to the product side. I'm adding 1 because I'm adding 3 because I have a 3 here for 3 waters, for 3 oxygens. Now, what do you want to add?
6.
All right, so 3 times 2 is 6. H's, H pluses, that is. All right, next. Check out the balance, the charges, and see how many electrons you need to add. So what's the total charge over here?
Oh.
So we have 6 plus and how many?
5.
1 minus, right? So we have 6 plus minus 1 leaves us at 5 plus. Right? So 5 plus charge over here. Over here, we have a total charge of 3 plus because the waters carry no charge. You always have to add electrons to the higher charge because that's how you bring the higher charge down, right? So how many electrons am I adding over here? 2 electrons. All right. And then we're done with that half reaction. Assuming we had another one, we could actually look at the electron transfer and multiply if we need to. Now let's do one more. Pick one. Go crazy, people.
Number 4.
Oh, let's do number 4 because we haven't had options on that side. Maybe we'll do number 3. All right, so we have chlorine gas yields chlorate. Okay, what do you want to do? I need to balance the chlorine first. Thank you. That's the one part people always forget because you don't always do it. So chlorine has a 2 over here. Chlorine now has a 2 over here. Yay. Next. Add H2O to which side? Reactant side, how many waters? 6. Thank you. 2 times 3 is 6 oxygens on the product side. I always thought facing you product sides over here for me. All right, so I'm going to add 6 waters here. All right, now I've got to add what? Right, 12 H pluses because I have 6 times 2, so I have 12 H's on the reactant side. So I need to add 12 H pluses over here. Okay, next. Charge balance. Okay, so this side carries a what charge? 0. No charges, period, over here. That's an H2O plus, not positive. All right, and then on this side? 10, right. So we have 12 pluses and we have 2 minuses, so that's a 10 plus. Where are you adding electrons? Product, how many of them? 10 electrons. You feeling it? You okay? All right, let's do a real problem. Let's do like one from your problem set, okay? This should be on your paper, yeah? It's not on your problem set, I think it's on your lecture notes. So it says B. You see it there? Do me a favor, I know you don't have room on there, but that's there so you don't always have to write down everything. Write down from this reaction the 2 half reactions. Yeah, on paper someplace.
What are we writing?
You need to take this example and write down the 2 half reactions.
OCL.
OCL is the same thing as CLO, 1 minus. Yeah. It's hypochlorite, it's just commonly written that way. Because like in bleach we have this thing. Bleach is sodium hypochlorite, but it's written like that. Okay, good. Huh? Yeah. Yeah, that's fine. Okay, so your 2 half reactions are, what is this called, people? Ooh. No. Thiosulfate. Okay, thiosulfate. Thio is that S one. I know it's weird. So your first half reaction is S2O3, 2 minus, yields. There's a fruit fly in here. It's in front of my face. Okay, yields this thing. I don't know what this one's called. Don't ask. Okay. Yeah, good. All right, first thing you want to do? Sulfur's good. Oh, it's not. I thought that was a 2. There we go. Sulfur's good. Now? Okay, so which one has higher oxygens? They're the same. Okay, are we good here? Yes, okay, next. Hydrogens? No hydrogens? Electrons. Okay. What's the total charge here?
4.
-4. And you don't have to write it, but I always write it because I always forget what I said. All right, so it's a 4 minus on that side. This side? 2 minus, which is higher. The 2 minus is more positive, right? So where are you going to add your electrons?
Product side.
To the product side. You're going to add your electrons to the product side because they need to go from a 2 minus all the way down to a 4 minus. I know the number line is like one of the hardest things. You're like, where is it on the number line? High or low? Okay. First one done. Second one. All right. Chlorine's balanced. Check. Oxygen's balanced. No. Where am I adding? So one oxygen on the one water on the product side, and now. Right. 2. So I have 2 H's there. 2 H pluses to the reactant side. Charge on the reactant side? 1. Positive 1, right? So we have a 2 plus and a 1 minus. Comes together, make a 1 plus. So 2 minus 1 is 1. And then this side, we have a 1 minus charge. So where am I adding electrons? To the reactants, how many? 2 electrons. Okay. Look at both of our half reactions. Equal number of electrons, yay or nay? Yay. Okay, so no multiplier needed. We have 2 electrons lost and gained. Who is reduced here? Which reactant is reduced? Right, the OCl, because you see your electrons on the right side. Okay, which one is oxidized? Thiosulfate. Yeah, thiosulfate. So you still have to be able to do that, just basically where the electrons exist. Okay, now you're going to sum them, and I'm going to bring everything down. So 2 thiosulfates plus, sometimes I don't bring everything down, I lied. Do I need to bring the electrons down, or do I know they're going to cancel? I know it. So I'm going to cancel them here to show that I know this, and I'm not going to waste my time because I'm going to write it again. 2 H pluses here, I have 1 OCl minus, I have products S4O6 2 minus plus Cl minus plus agua. Anything else I can cancel? No. Okay. You do 2, 3. Continue until I tell you to stop. I'm going to try to cut down some of these though, because I'm realizing that there's just too much homework sometimes. Try and protect your time some. So work together on these for another, I don't know, 10, 15 minutes. Get as many as you can. Yeah, I'll tell you specifically though which ones are homework after we do these. Okay. So these are going to be classwork, and then I'll tell you which ones I want you to do for homework. Okay, these are all the answers for the first 5. If you got them right, pat yourself on the back. Yay! And let's do, this thing's acting up.